probably got the most challenging talk of the day, I think, because strategic tillage is probably one of the biggest challenges facing our business when it comes to soil testing. Changing the soil profiles, and we've got guys with years and years of soil data, and then we're going through ripping inclusion plates, lime, delving, the whole profile's changed, we're basically starting again. So I don't have really too many answers for you. I can talk about what to look out for, talk about some of the work that's going on behind the scenes, but the complexity of this issue is huge. So at the moment, GRDC have actually got some money they're putting towards a couple of projects in the pipeline, specifically looking at soil sampling in these different practices. So like Tristan said, I grew up at Lameroo, so I spent last week touring around Esperance, so it's good to come back to somewhere and be a bit more realistic again. So very much grew up farming sandhills essentially, a bit like CD said in the YP, that dune swale type system. So the history of APAL, just a real quick one, it was an American franchise. So when we took it over in January 14, we had a real focus on test methods. The opportunity for us was that the soil testing industry has been dominated by the two fertiliser companies in Australia for the last 20, 30 years. For that reason, we have not seen much innovation. Soil testing's worked as a tool to sell fertiliser, happy days. Like, how many new soil tests have we seen in the last 20 years? Not too many that have got traction. So we saw the opportunity for an independent provider in the market. So we've rebranded to Australian Precision Ag Lab. So now we've got sites in Adelaide and Perth. So with that, we got it right with the need for that independent service. We've gone from 15,000 samples to 100,000 in 3 years. So there is that demand for an independent service out there. So like I said, we're sort of bringing that science back, real focus on farming. That's who we are, what we do. Trying to deliver innovation. So today I really want to talk about a project we've had with Adelaide Uni, which is going to really play a big role, particularly in this simulation space. And we provide a lot of support to our clients too. So work closely with agronomists, consultants, farmers in interpreting data, what's next, where do we go. We've since progressed into very much a research focus as well. So a lot of you will be familiar with Sean Mason, developed the DGT phosphorus. So he's a business partner in this business which is focused purely on research in soils and nutrition. So we've got 18 sites this year between SA and WA, of which majority of them nitrogen and phosphorus focused. We are doing some work with potassium in deep brick soils in Geraldton, so along the strategic tillage line. So just quickly, the no-till system, there's no doubt huge benefits. The yield gains we've got from that system is just absolutely phenomenal. As CD pointed out, that 800 kilos is just to where we are now. We all know the benefits, you can see them there. The big question is, where are those next yield gains going to come from? We're not going to see that again from no-till. I think really my opinion of that is our next yield gains are going to come from understanding soils better, and the big, I suppose, elephant in the room, understanding the biological systems in our soils. Are there any negatives? So we've created a system very reliant on chemical. Nutrient stratification. Does everyone know what nutrient stratification is? Movement of nutrition, mobile, immobile elements, where they sit in the profile. So what has the no-till system done to that, which I'll talk about? And that's pretty much what I'm going to focus on today. And then the strategic tillage, altering and changing soil profiles. What are we doing? And soil-borne disease is one a lot of people talk about too, that the no-till system has driven that. So soil sampling challenges, this is the big one. So back in an old system, we were working up, working back, spreading phosphorus, putting it down. We've got a pretty good distribution of phosphorus in our profile, correct? What's happened with a no-till system where we're year in, year out, we're generally going back in a pretty similar spot? We very much understand, we talk about vertical stratification, so mobile nutrients, nitrogen, sulphur, potassium to a lesser extent in sandy soils. We understand that pretty well. What about horizontal stratification? So exactly that. Where's our immobile element, so phosphorus, sitting in that profile? So we're currently, through a GRDC project, looking at, so it's a 12-month review, of which we've gone, there's a few long-term strategic tillage trials, Hart, a couple over in Victoria around Horsham. So what we've gone back and actually resampled these all. So we've got between the row, got mid-row, and we've got in the row. So what we've actually done is we've sampled that from 0 to 2.5 centimetres, 2.5 to 5, 5 to 10, 10 to 15, and 15 to 20. So we can actually build a pretty good profile of where that nutrition is sitting in that system. So different systems, we've got time, disc, and then a conventional comparison. So the answer isn't there yet, but that's some of the work that's going in the system. But it's one of the key points too, when we're looking at inverting profiles, changing soil profiles, we need to understand what that's doing to our soil nutrition. Make sense? Yep, beautiful. So, general soil sampling. How many people soil sample? How many people think you soil sample enough? Agree. South Australia's, we're definitely getting left behind the 8 ball as far as soil sampling and how we're applying that to our operations. One of the big things which the precision ag game is bringing to the table when making farmers recognise more, which is fantastic for us, is this variability we've got in our paddocks. So whether it's an EM map, whether it's a yield map, what it is. Is anyone still taking transects through paddocks? So, yep. What would happen if you took that transect, you started here, through to here and took 30 cores? Do you think that would be representative of the paddock? Not at all. So what the industry's moved to now is site-specific sampling. So we're sampling to specific soil types within that paddock. So we might have 2, 3, 4, 5 actual sites within that paddock itself. It's a client of ours in WA, similar rainfall to here. That's all his soil sampling sites on his farm. Now, where does he get benefit from this? Variable rates lime, variable rates phosphorus, variable rates potassium, all three. So he's got a very stringent monitoring program whereby he'll go through and he actually selects his sites each year based on the previous year's results and the year before. So if he starts to see this yellow pop up, if he sees the red, he knows he's deficient. If he starts to see this yellow pop up, he goes, "They're my sites, I'm going to test for this next year," and just see where they're up to. Because last time he tested them, they were in or around that critical level and were getting close to responsive. So the key message there is forget transect testing, get more specific about your soil testing to those soil-specific sites, and then look at where you go from there. There's not too many paddocks where even we think there's no variability, there's normally variability. The big pain in our backside at the moment is soil sampling to add to the complexity of these sites. WA, as Chris mentioned, ripping on sandy soils, particularly north, so Geraldton, up through that country, with inclusion plates. So the idea of the inclusion plates, so you saw the pictures this morning, they sit on the back of the tine, they spread lime first, so then the idea there is the organic matter in the lime falls down the profile. Limitations, the conditions almost have to be ideal to get that fall. If it's too wet, you just get that slicing of the soil and it doesn't work. A lot of farmers, we're coming back and we've got historic data, all of a sudden we're getting these pH readings at 50 centimetres of 7.5, and it's really added to the complexity of interpretation, because all that lime and organic matter that's fallen down, all of a sudden that was 4.2 not long ago. And we're seeing that variability across the paddock because it's not always getting down there. So it's added very much, like I said, made our job pretty tough. As far as what you're getting from a soil test, we've got 3 strategies. We're either building it because there's not enough of it, we've got shitloads of it, so we're mining it. Ideal, it's cheap. Or we want to maintain it. So we never want to run our soils down. We want to make sure that they stay at a good nutritional level. So basically, put it in simple terms, response to fertiliser. If we're in that low category, we're pretty confident you're going to get a response. If you're in that sort of critical level as such, or sufficient range, you're not likely to get a response. You might, but we're probably going to look at maintaining it. So look at maintaining our levels in that range. In that higher range, it's very likely you're not going to get a response. The only sort of issue there is if you get into some real sodic, high K magnesium, we might run into some nutrient interaction issues, but we generally don't see them in broadacre anyway. Sampling depth. So this is where the sort of complexity, I suppose, going away from nutritional recommendations and looking at strategic tillage as such. So conventionally we'd sample from 0 to 10, because that's where the critical levels are set up for in that depth. But in this case, what's below that 15 is really what we need to focus on. Generally, we're very good at going down to whether it be 70, 90 metre, understanding where your rooting depth is, so we can budget for mobile nutrients. But in this case, we're looking at constraints. So what's down there? Are we going to alter that soil profile? Are we going to cause issues? I know this country, particularly on our place, that a lot of clay spreading, but we've had some, initially I think it was just too high a rate, but country that pretty much didn't grow a crop for 5 years. What that is, we've very much got that boron toxicity layer up in the mallee as well, which is an issue. It's not really salinity, but very high pH subsoils as well, so we've caused some issues there. So, all different forms of strategic tillage. Farmers were great, just go in, let's burn some diesel and rip some ground. The key message, what are you trying to fix? So, have we got someone help out? Strategic tillage here. What are you trying to fix? Subsoil constraints. Yep. Compaction. Yeah. So, you need to really have a good idea of what you're trying to do. Obviously, how are we changing that soil profile? What clay rate do we put on if we're spreading? How heavy do we need to go? Have I got boron? Have I got sodic or saline subsoils? South Australia, carbonate, something we've got to be very careful, and I suspect that's what CD's done in that photo you saw. They've brought up a heap of calcium carbonate, ties up particularly trace elements of phosphorus, so it would have induced that manganese deficiency. And then what are the implications of that? So, what's happened to that biological activity if you've dropped that all down? What's happened to our water capacity, water holding capacity? There's been some reports out of the Sandy Soils project that Chris was talking about nitrogen tie-up. You've dropped or potentially taken all your soil carbon out of that top 10 centimetres where you're growing the crop. So there's all these things we need to consider. Use this as an example. So duplex soil, sand over clay, which would be pretty common around here. Yes? Yeah. So the question is, we've got this probably down to 30 odd centimetres, we've got this sand. If we go into this, what are we actually going to bring up? We've got poor water holding capacity in the top, we've got non-wetting at the top, low fertility, low microbial activity, and potentially compaction in sand. So they're all sort of different issues we're trying to fix, really. You look at the ripping they're doing in WA, in the sand, it's all basically driven by fixing subsoil compaction and subsoil acidity. But in a situation like that, 90% of your compaction happens in the first pass. So unless you're on controlled traffic, that's not really, you're going to be going back every couple of years doing it. So really focusing on understanding the chemical and physical nature of that soil before we go. As an example, pH. So this soil at 2.5 centimetres has got a pH of 5.8. At 4.5 centimetres, at 5 centimetres, it's got a pH of 4.5. At 30 centimetres, we're up to the 8 to 9 mark. So it's something to even consider when we're doing, 0 to 10 sampling. We've got 5.8, 4.5, that's pretty low. Our seed's going to be down below that. We're diluting out, essentially. So when we're characterising soils, particularly for this process, you need to make sure you characterise them well. So that is having a look at different layers and testing them separately. So in this case, you can see 3 distinct layers. We've got there, and we've got there, and then the clay. So if I was doing any sort of strategic tillage on this soil, I would take a sample there, sample here, and a sample there. Ideally, in 10 centimetre increments works the best for characterisation. We just go down 10 centimetre increments down to wherever we're going to affect, basically. It's the easiest way or basic way to do it. What are some of the issues down here? Generally alkalinity in WA, and is showing up more and more in SA now, is subsoil acidity, so that 20 to 30 centimetre layer. Might be sodicity, salinity, nutrient stratification. So, like I said before, if all your phosphorus is very immobile, generally it stays where we put it, what's going to happen? What's the implication of your next crop if you get rid of all that phosphorus? So understanding this is crucial. Soil texture is another one that's very important to understand, particularly with clay spreading, because we can have a look at generally what sort of rates to apply. I was actually on a phone hookup last night with one of the girls from the Sandy Soil Project, Mel Fraser, and we were talking about this, and she was out with a farmer in the Mallee yesterday, and she asked how does he test his clay before he spreads, because he does a hell of a lot of acres. And he said, yes, I dig up a few clods and I piss on them. And if they break down, I reckon it's all right. So if they don't, it's no good. So there is a bit more technical way than that of doing it. Particle size analysis is part of that characterisation. Is very important when we're looking at soils. You need to understand, how much clay is there, how much sand's there, how much silt. Soil texture basically influences everything we do. That physical side of things, even the chemical properties of our soil, the nutritional or critical levels will change with soil texture. So very important. Carbonates, SA, very important. Understand where they are, what you're going to do to that soil profile. Phosphorus, that's why we have huge issues with P fixing, particularly YP, is that carbonate calcareous soils. And we see a lot of that manganese deficiency in those soil types as well. So, does that all make sense? It's incredibly complex. We're changing soil profiles. So, where we go as far as soil testing really needs work. When we go through that, the key is to understand it before you do it, is the driver. So, the other thing to really, clay alone is not going to fix something. I'm going to have a crack at an analogy. We spoke on the phone last night. We'll see how it goes. So, if we look at a car, right? So, that's our vehicle for growing crops. The engine in that car is what grows the crops. So, if we look at the engine and refer to the engine as that soil type, so the engine is our soil type that's growing the crop. By putting clay into that or incorporating clay, we're increasing the capacity of that engine. So it's going from 4-cylinder, 6-cylinder, or ideally a V8. So that's all good. All of a sudden, we've changed this soil profile. We've had this little Mazda 323, now we're driving an SSU. If that U has got no oil in it, and if we refer to the oil as the biological system, what's going to happen? Nothing. It's going to go to shit pretty well. If we turbocharge that ute and add a heap of nutrition, we've got another complexity to deal with. So my key message here is It's about balance as well. And Nigel mentioned that before with the sand. You know, we need to get something else down with it. Clay's not going to drive everything, it's going to help. It's the combination of clay, organic matter and nutrition, and the magic one at the end. Fortunately, that whole system is driven by, as we know, water. So rain's going to fast track. 5, righto, easy. So when we're looking at soils, what we need to do, we identify the issue, we identify what's there, and we need to look at what's going to fix it. Because I have heard some reports out of the Sandy Soil Project, and don't quote me on this, read the reports when it comes out, but there has been some detrimental effects to clay alone, there's been some good effects with combinations, and so that's really encourage you to keep an eye out for when that report comes out. How do we characterise these soils? Pretty exciting technology we've been working on the last 2 years with Mike McLaughlin's group at Adelaide Uni and CSIRO. Mid-infrared and near-infrared. Huge amount of investment's gone into it. Essentially where I see, so the Sandy New Horizons project they had 3,000 samples they needed to analyse. They didn't have the budget, obviously wet chemistry on that was going to be out. So what we did, we scanned all those soils by MIR. That was able to group those soils or characterise those soils basically into different groups. We ran 300 wet chemistries, so 10%, and we're able to predict the whole of the rest of the results. So how that applies to farm, potentially in the precision ag space, particularly, this has got huge potential for characterising farms based on potentially grid sampling, actually gridding and then coming back and doing sort of reduced amount of wet chemistry. So this robot, compare that, that's probably a 300 horsepower John Deere sitting there, just in comparison. So essentially this is just the machine that's getting built at the moment. Normally we'd add a chemical extractant, shake it overnight, we're trying to predict what's in the soil. This thing uses an infrared beam, so it uses mid-infrared and near-infrared to basically just scan the soil. So we grind it, we scan it, it gives us a result. Very important, so we've got 20,000 soils in the database at the moment, so it's all the models are validated against wet chemistry. This thing will never replace wet chemistry because we always need quality control. Any instrument, doesn't matter what it is, even, you know, we've got $250,000 bits of kit in the lab, they drift, they change, electrodes change. So you need that quality control. So 1 in 10 will always go back through the lab. At the moment, we've got very good results for organic carbon, total nitrogen, particle size analysis, so clay silt sand, as we spoke about before, carbonate, cation exchange, PBI, bulk density, and we've just got a project with the Riverina Plains where we're getting pretty good results for water upper and lower limits and actually predicting them. So this is really going to change the face of soil testing, essentially. The information we're going to gather is just phenomenal, so which brings another challenge. Clay silt sand. So to explain an R squared, ignore the graphs. We want a value of 1, so then that means the result that mid-infrared is giving us is exactly the same as a wet chemistry result. Be 1, we're running at 0.91. So it's incredibly accurate. There's only one of them that's running under 0.9, and that's cation exchange. So, plant material. Now we've taken this to the field as well through a Saget project, looking at doing total nitrogen in the field with this. To give you an idea, 0.96, 0.98 for nitrogen, 0.92, 0.96 for potassium. So potentially you send me a plant, you can have a result in 2 hours. So, and then ideal scenario, we get this to a point where we can take it to the field. So agro, Batesy, someone can have one of the ute, run out, scan it, bang, have a result right then and there. I think it's a long way off, but I think it's achievable. Just to finish off, other than strategic tillage giving us a major headache as far as soil testing, does anyone know what that is? Is anyone windrowing on sandy soils for weed control or stubble? Yep. Windrow effect in WA. If you drive through WA now, this has become a massive issue in the last probably 3 or 4 years. Basically what's been happening here, windrowing, redistribution of nutrients into the windrow. And now if you drive through WA, basically anywhere, you'll see crops like this. So, heads up, something to be very careful of, because we've got it through trial sites, we've got it everywhere. Redistribution of nutrients with stubble, burning on sandy soils, be very cautious. And that'll be done and dusted.
Thanks, Ryan.
In the next 4 weeks, mate, that robot lands. So, yeah, the major issue has been capacity through, obviously it's a research instrument. It's used all over the world, just not in Australia, unfortunately, and different industries. But the research capacity is only sort of 1,000 scans a day type thing. So the new robot will do 25,000 scans a day. So lots of samples. Yeah, generally leading up to seeding, obviously. You can do it any time for most nutrients other than nitrogen and sulphur, like, doing that nitrogen testing in December, and then we're relying on, what's our nitrogen levels. You're better off doing that as close to seeding as possible. As well, there was a GRDC project we were involved with last year looking at sampling at GS30, or pre-GS30, in the row, and there was excellent correlations with sites on the EP and YP with relating that to nitrogen requirements. So I would say with anything else, timing doesn't matter. Nitrogen either do leading up to crop, or I'm more of a fan these days of in-crop, if you can handle it. It's got some challenges, obviously, with wet soils, those type of things. But pre-GS30, right, do your nitrogen then. Phosphorus anytime from now on. So, yeah, absolutely. Because that sandy soil is very potassium deficient. You can quite often see, with burning, you lose a lot of N, but you sort of only lose 40% of N and P, roughly. So, quite often those windrows can be nitrogen responses. There's a lot of argument as well that it's actually moisture retention, so a lot of stubble load sitting there. Answer is probably 80% potassium would be likely. We're doing a lot of biomass cuts in front of headers this year from different things and then out the back, and we're going to try and map out actually what happens.